I hope you have done your unit test and NEET test in a very successful way. With that successful way, come let us move into the next topic, part 3 of our lesson, which starts with errors. Errors means mistake. That is your actual English meaning for it. In physics, errors refers to the difference between actual value and the observed value. I'll tell you, this is the statement. I'll tell you a real time example. For example, if your watch is set by 2 minutes late, right? So you don't know that it is going by 2 minutes late. But you got attached with that time which is 2 minutes late. For in the morning, if you are waking up at 6 o'clock, the actual time is 6 o'clock. Means what your watch will show? 6:02, right? So in a full day, every activity of yours will be delayed by 2 minutes. Now come, let us go into the definition. It is a difference between actual value. Actual value is 6 o'clock. What is the observed value? 6:02. What is the difference? Difference means subtraction, as you know. 6:02 minus 6. 2 minutes is your error. Can you understand, children? Right. Now, this error is divided into 2 types. Systematic error and random error. Systematic error is that what I told you now. From morning till the end of the day, if you don't realize that watch is going late by 2 minutes, every activity of your work will be delayed by 2 minutes. So that is what is given. Errors which shift all measurements in a systematic way. Throughout the day, every action of yours will be delayed by 2 minutes. So that type of errors are called systematic errors. Random error. This is one super type of error which doesn't have any reason. But we don't know because of what mistake this error had happened. We cannot correctly diagnose, correctly identify due to this only this error can had happened. For example, if you are measuring your bench, right? Bench or your stool, whatever it is. If you measure, it may come around 50 centimeter. If some other people measure it, it may come around 52 or something. Right? In that, you cannot correctly diagnose how it came to 2 centimeter in a wrong way. So, correctly we cannot say because of this only this error had happened. Such type of errors are called random errors. So, this goes into deeper, which you will learn in your higher classes. So, as of now, in this 7th standard, you stop with these 2 types. What are the 2 types? Systematic error and random error. Okay. Now, with that, let us move into the next topic. Significant figures. Say the word significant. S-I-G-N-I-F-I-C-A-N-T. Significant means what, more children? Important, meaningful. If I have a number will have so many digits. Yes, of course. 1000 is a number. 1000 will have how many digits? 1 and 3 zeros. So totally it will have 4 digits. In that, as per physics, we call that number with one word called as significant figures, which means the number of, note it down, the number of meaningful digits in a number. Now you can ask me, ma'am, how digits will have meaning? Yes, it is having meaning. So now say the definition again. The number of meaningful digits in a number. Digits mean individual numbers. Full number is called as, full digits combined is called as number. In that number, the meaningful digits are called significant figures. Now we have 5 rules for that. Come, let us learn that rules with examples. Number 1. All non-zero digits are significant. All non-zeros. Non-zero means other than 0. Now this example I have given here in an expanded way. Right? 4, 3, 6, 2. Can you find any 0 here? No. So these numbers are called as non-zero numbers. Now you come to the rule. all non-zero digits are significant. So no zeros are here. So all these numbers are non-zero numbers. So how many figures, significant figures here? 1, 2, 3, 4. Ma'am, how what 4 is read as 1? Not like that. You count the number. Right? 1, 2, 3, 4. So you have 4 significant figures in this number. If that number doesn't contain any zero. Right? Now come to the second rule. All zeros occurring between non-zero digits are significant figures. I am reading it once again. All zeros occurring between non-zero digits are significant. Now you come to this. 1005. Here 1 I said, 5. Now you see this number, all zeros. Here how many zeros are there? 2 zeros. Occurring between non-zero. 1 is a non-zero number, 5 is a non-zero number. These 2 zeros, which is occurring between non-zero numbers, they are significant numbers, significant figures. Here I said, don't get confused. Here I said non-zero numbers are significant. Here zeros are significant if it comes in between non-zero numbers. Clear? Now count the numbers 1, 2, 3, 4. So how many significant figures in this? 4 significant figures. Clear? Now come to the third rule. All zeros to the right of the last non-zero digit are not significant. Now you see here, significant, significant. Now you are going to the rule, not significant. Be clear. When you are writing an examination, this will confuse you. But it is a very, very important question, very sure question. So you have to be very thorough, understand, practice it, then memorize it. Okay? Right. All zeros to the right of the last non-zero digit. See here. Here 625. What is the last digit? 0. Where is that 0? Next to the last non-zero digit. What is the last non-zero digit? 5. So if a 0 comes like this, after a non-zero number, that 0 should come at the last of the number. Then that 0 is not significant. Simple children. If a 0 comes at the last, it is not significant. If it comes in between, it is significant. Now this 0 is not significant. So how many numbers you have? 3. So then the significant figures is 3. Can you understand? Now come to the next one. In a digit less than 1, all zeros to the right of the decimal point and to the left of a non-zero digit are not significant. I am reading it once again. All zeros to the right of the decimal point and to the left of a non-zero digit. Now you see, this condition goes for a number which is less than 1. Less than 1 means it should come in decimal. Okay, decimal number we are having. After the decimal point, how many zeros we have? 2 zeros. That 2 zeros comes before the non-zero digit. Non-zero digit. Which is the non-zero digit? 3. Where that 2 zeros comes? After the decimal point. So if 0 comes after a decimal digit, before the non-zero number, then that zeros are also not significant. So how many digits are there? Meaningful digits 1, 2, 3. Clear? Now coming to the next one. All zeros to the right of a non-zero digit in the decimal part are significant. Right? In a decimal number, if all the zeros coming to the right, they are all significant. So now count here 1, 2, 3, 4, 5. So you will get numerous confusion in this, children. Practice these rules one by one. Right? Then apply it in the sums. Now take your book with these rules, page number 11. You have 5 exercises on the top, 5 questions. You have it as homework. Practice it with these rules, find the answers for it. Leave that 5th one, do the first 4 one. Clear, children? So with that, we will end this, then we will continue with another topic.